Good morning students. Today we will solve some NCERT questions from NCERT exercise. Okay. Question number 1. In question number 1, the given values are Q1 and Q2 and R. Or we find the value of F. So we apply the formula F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. By putting the value in this formula, we get the answer. Okay? Calculation is yours. Question number 2. In question number 2, the value of Q1 Q2 and F is given. You are finding R. So similarly, by applying the formula F is equal to 1 upon 4 by epsilon naught Q1 Q2 upon R square, we can find R square, then R. Okay? Then R आप find कर सकते हैं यहाँ पे. Okay? In the second part of question number 2, the question is saying that what is the force on other charge? Then according to Newton third law, force on first charge due to second charge is same as force on second charge due to first charge, that is 0.2 Newton. Okay. The answer of question number 2b is 0.2 Newton. Okay. In question number 3, question is saying that the ratio ke square upon g me mp is dimensionless. So we apply the units of these quantities. Then you know that the dimensions of k is Newton meter square per coulomb square. E is charge and square is also there, so coulomb square. Similarly, the unit of universal gravitational constant is Newton meter square per kg square, and mass of electron, mass of proton is there, so kg square. You can see that all are cancelled with each other, so this quantity, this ratio is dimensionless. When you put the value of these constants in this ratio, you get a large value. So this ratio represents Coulomb's force, means upper part. Coulomb force is much larger than gravitational force. Okay. In question number 4, question is saying that a charge is quantized. The answer of this question is all free charges are integral multiple of basic unit of charge. This means charge is quantized. Okay. By this formula we can show that. Okay. In the second part of question number 4, question is saying that can we ignore the quantization at macroscopic level? एक बड़े लेवल पे क्या हम क्वांटाइजेशन को छोड़ सकते हैं? तो बिल्कुल छोड़ सकते हैं. कैसे छोड़ सकते हैं? कि E की जो वैल्यू होती है 1.6 10 to the power minus 19, किसमें? कूलम्ब में. कैसी है ये? Is very small. So we can neglect this value at macroscopic level. Okay. So at macroscopic level, quantization is lost. Okay. In question number 5, question is saying that when a glass rod is rubbed with silk cloth, a glass rod rubbed with silk cloth, then this follow the conservation of charge. Yes, charge is conserved because charge gained by glass rod is equal to charge lost by silk cloth. Okay. Come to the question number 6. In question number 6, question is saying that there are 4 charges at the vertices of a square and 1 microcoulomb charge is placed at its center. Then find the total force on the center of square. Then you can see from the diagram FA and FC are opposite to each other. FB and FD are opposite to each other. Then total force F is equal to the sum of all forces FA, FB, FC, FD. Okay? But we also know that from the diagram FC is equal to minus FA, FD is equal to minus FB. Then by putting the value we get total force is 0. Okay? Question number 7. In question number 7, a question is saying that electric field lines are continuous curve. Yes, because for a single charge they may start or end at infinity. Okay, and the next part of this question saying that if they break, then electric field is 0 at that point. So they never breaks. If charge is there, they goes to infinity. Okay. Question number 8. In question number 8, two charges are given, 3 microcoulomb and minus 3 microcoulomb on point A and B, and question is saying that find the value of electric field at the center of this system. For midpoint or for center, the distance of both the charges is 5 centimeters because total distance is 10 centimeter. Okay, then EA is equal to 1 upon 4 pi epsilon naught QA upon R square. You know this formula. Similarly, EB is equal to 1 upon 4 pi epsilon naught QB upon R square. Okay. Total electric field at point O is 1 upon 4 pi epsilon naught, 1 upon R square is common from both. Then we get QA minus QB. Since QA and QB both are same, so we get 0. Total electric field at point O is 0. In the second part of question number 8, charge is given to you. Okay? Charge is given to you and you are calculating the electric field. By putting both the values in this formula, you get the total force on charge Q. Okay? Come back to the theory part. The new topic is electric flux. Okay? What is electric flux? Electric flux is the total number of electric field lines. Total number of electric field lines passes through a surface. Okay? If a number of electric field lines passes through a surface, then this is electric flux. It is also defined as dot product. Most of the students know about the dot product. Okay? So, dot product of electric field and area vector is called electric flux. But you know that area is a scalar quantity. So, here area is a vector quantity and the direction of area vector is normal, means perpendicular to the surface. Okay? Come, electric flux through an area element ds. Okay? That is d phi is equal to E into ds. As you know that in dot product E into ds is equal to E ds cos theta. But when E and ds both are in same direction, then theta is equal to 0. Put the value of theta, d phi is equal to E ds cos 0, that is E into ds, because the value of cos 0 is equal to 1. Okay. Now we are finding the total electric flux passes through area A. Okay. So we give the integration of d phi equal to integration of E into ds. Okay. Because electric field is constant, so it taken out, then phi is equal to E integration ds. Then we get phi is equal to EA, the product of electric field and area vector. Okay, where A is equal to integration of ds. Getting or not? Yes. SI unit of electric flux is Newton meter square upon Coulomb. Okay, or Newton meter square per Coulomb. Okay, dimensional formula M L T minus 3 A minus 1. Okay, it is a scalar quantity. Why it is a scalar quantity? Because in the definition you can see that total number. So number is a scalar quantity. In this way, electric flux is a scalar quantity. Okay. Then come to the electric dipole. Di means दो, पोल एक ऐसा सिस्टम जिसमें दो चार्जेस हों उसको हम क्या बोलेंगे? डाइपोल. सो इलेक्ट्रिक डाइपोल इज अ सिस्टम of two equal and opposite charges separated by a small distance. Okay, two equal and opposite charges separated by a small distance is called electric dipole. The direction of electric dipole is from negative to positive. That is, okay, midpoint is called center. This is, okay, total charge of dipole is 0 because there are two charges of equal magnitude but opposite sign. So the sum of these two charges is equal to 0. The distance 2a is called dipole length. Here we are taking r is equal to 2a. Okay. Now electric dipole moment. What is electric dipole moment? The product of magnitude of either charge and dipole length is called dipole moment. That is, P is equal to Q into 2A. Okay, in vector notation, P is equal to Q into 2A with unit vector P. As you know that it is a vector quantity. Okay. Now, in case of electric dipole, there are two lines. One is axial line, another is equatorial line. So we are calculating the electric field at a point on axial line. What is axial line? Axial line is a line which passes through the center in the plane of dipole. डाइपोल के प्लेन में ही उसके सेंटर से पास होने वाली लाइन को आप एक्सियल लाइन बोलते हैं. ओके, सो टू कैलकुलेट द इलेक्ट्रिक फील्ड consider a point P, at a distance r, from the center of dipole. Okay, electric field at point P due to charge plus q is E plus q. Okay, that is 1 upon 4 pi epsilon naught q upon r minus a whole square, because for plus q charge the distance is r minus a. Okay, electric field at point P due to charge minus q, that is E minus q is equal to 1 upon 4 pi epsilon naught minus q r plus a whole square, because for minus q charge the distance is r plus a. Okay, total electric field at point P due to dipole, that is E is equal to E plus q plus E minus q, means sum of E plus q and E minus q. Okay, by putting the value we get E is equal to q upon 4 pi epsilon naught, means this quantity is constant in both, so we take this common, then we have 1 upon r minus a square minus 1 upon r plus a square, then E is equal to q upon 4 pi epsilon naught. By taking LCM, you know that by taking LCM we get r plus a square minus r minus a square. Okay, then we use the one identity, a square minus b square, then by this we get E is equal to q upon 4 pi epsilon naught 2r 2a upon r square minus a square to the whole square. Okay, then if we take q into 2a into 2r upon 4 pi epsilon naught r square minus a square whole square. Okay, then we know that q into 2a is p, so put the value of p into 2r upon 4 pi epsilon naught r square minus a square whole square. 4 are much larger than 8, then we can neglect a square, so we get E is equal to p into 2r upon 4 pi epsilon naught r to the power 4 to the power 2, so 4. By cancelling one power we get E is equal to 1 upon 4 pi epsilon naught to p upon r cube, which is the required expression, which is the required value of electric field on axial line. In vector form, E is equal to 1 upon 4 pi epsilon naught to p vector upon r cube. Okay,